This is Algebra 2 at Trig, working on Unit 2B.2a. We're adding and subtracting and multiplying polynomials. So we look at this first one and we see that we have a plus in between the parentheses. So having a plus in between the parentheses is going to tell us to add these two polynomials, but the parentheses really aren't needed. So if you would like, you could take your negative 5x cubed and you could write that underneath the x cubed with the first polynomial, and the negative 2x squared, the negative 4x, and the negative 4. These happen to all be negative, but we're adding them. We're just collecting like terms. So this is going to be a negative x cubed, a positive 2x squared, negative 7x, and a plus 6. Notice that when we're working with adding or subtracting polynomials together, the exponents don't change. When you add or subtract, you don't change exponents, but you are required to group them together. You can only work with x cubes with the x cubes and the x squareds with the x squareds. Where in multiplying, it doesn't matter what your exponents are, you just end up adding them all together. Over here for the second one, we notice that there is a negative before this set of parentheses, this polynomial. Now, the parentheses are very much needed because this is telling you that you need to distribute this negative through. When you do that, this is going to become a positive x cubed, a negative 6x squared, a negative 9x, and a positive 3. Now, it's your choice how you want to organize this. Once we've used the negative, it would be considered a positive. So now you can just bring them over. You have a 4x cubed, which is a positive 4x cubed. You have a negative 6x squared, a negative 9x, and a positive 3. So I'm just collecting my like terms. I'm putting them in a row because it's a little bit easier to add that way. That would be 7x cubed minus 2x squared minus 2x plus 15. So we've collected our like terms. First we distributed, so we had the correct sign, and then we collected our like terms. So moving on to h and k with the next one. Now notice what this looks like. This has h of x minus k of x. We have to look up to figure out what is the h of x function. What is the k function? So the h function is 3x squared minus 4x plus 7. That is your h function, minus the k function. You need to be sure that you're going to minus the entire function. So this is where you must use parentheses. We're minusing k, so that is an 8x plus 2x squared minus 3 plus 9x cubed. First thing we would do would be to distribute your negative sign through the parentheses. So all the signs are going to change. Now what we've done in the past, we have moved our terms underneath the like term, and we added them together. It's a great way to do it. The other option is just to bring this down, and now you're just going to look for your like terms. You look for your largest exponent, and your largest exponent is going to be over here. So I'm going to cross it off because I want to point out that I've used it, but I'm just collecting like terms. So now if this is a cube, now I'm looking for all the squareds. So I got a 3x squared and a negative 2x squared. That gives me a positive 1x squared. I've got a negative 4x and a negative 8x. Which is giving us negative 12x. And we have 7 and 3, which is 10. So we're just grouping our like terms together. So notice I typically go through here and cross off everything that we've used, just in case I've missed something. And the common time you miss something is when there happens to be 3 terms of the same type. That just helps you stay organized to be sure that you're going to add or group together all the terms. So for our next one over here, we have k of x plus g of x. So your k function is 8x plus 2x squared minus 3 plus 9x squared. And we're going to add the g function, 3x squared minus 4x minus 2. So here we could write our like terms underneath each other to organize it out, or you can just, it's called grouping like terms. So we have no cubes. There are no x to the third powers here. So we have 9x squared and we have 3x squared. That's going to give us 12x squared. Oh, let's see. Did I write this one out correctly?
It's 9x cubed.
This should be a 9x cubed. My fault. So if that's a 9x cubed, that was what we were looking for. That seemed a little weird before. 9x cubed. So now we can do the x squared. So there are 5 of them. And then with the x's, there would be 4 of them left because you have a positive 8 and a negative 4. And then we're left with negative 5. So you typically want to write these in standard form when you get to the end. That's the largest exponent first in the descending order. The f function, 4x cubed plus 9, and the g function, 3x squared minus 4x minus 2. Well, you look at your largest exponent first, and you got 4 of them. And then you have 3x squareds. So we've used that one, we've used that one. Next we have a negative 4x. We've used that one. And then these two get grouped together to become 7. When you subtract 2 polynomials, this is the time where you must use parentheses. So we're going to have our 3x squared minus 4x minus 2 minus the h function. And that happens to be 3x squared minus 4x plus 7. So you've got to distribute that negative, so all the signs are going to change. So it becomes a negative 3x squared, a positive 4x, and a negative 7. The 3x squareds are going to cross out, so you could call that 0x squared if you like. The x's are going to cross out, so you'd call that 0x's. And then when you group the constants together, you're going to get negative 9. So your best answer is to call it negative 9. So that's adding and subtracting polynomials. Pretty straightforward. The main thing that you need to focus on is that the exponents don't change. You don't move the exponents. You don't group them or add them together. You only group them. You would group them together. You would not add them together. Here we're going to multiply polynomials. When you multiply polynomials, we're going to take one of our parentheses has to go first. It really doesn't matter which one. If you want to take the front one, we'll do 3x squared times 2x. That gives us 6x cubed. This is where you add exponents. When you are multiplying, you have a 3 times 2, that makes 6. You have an x squared and an x. That is 2 of them and 1 of them, which makes 3 of them. The exponents change for multiplying. They do not change for adding or subtracting. So then multiply the 3 to get 9x squared plus 6x squared plus 9x. And then the 5 times the 2 becomes 10x. And the 5 times the 3 becomes 15. So we're going to take the one parenthesis and multiply the other parenthesis all the way through each term. So again, we're collecting like terms. We have 6x cubes, and we've used that one. Here we have 9 and 6, which is 15. X squareds, 9 and 10, which is 19 x's, and 15. So that would be the product of our two polynomials. Here's a different notation for it. The f function times the g function. Well, if this is going to be considered our f function, and this here is considered our g function, we could take the x squared minus 2x plus 3 and times that to the x minus 5. And we'll just go through and do the same thing. We can go the other direction if you want. I usually like to start with the smaller number of terms. X times x squared would give you x cubed. X times 2x would give you negative 2x squared. And x times 3 would give you 3x. And then the negative 5 times x squared, the negative 5 times 2x, negative and a negative is a positive, 5 and 2 is 10, the x times no x's is just an x, negative 5 times 3 is negative 15. So we've collected all our like terms together, which brings us to our product of our two polynomials. We have a trinomial times a binomial. It's not much different even if you're working with 3 terms. We have 3 binomials. When we multiply 3 binomials, we're going to multiply those. So that means we're going to FOIL them together. X times x gives us x squared minus x, and 2 negatives make a positive 1. So that's what we have so far. And when we collect our like terms, we have a trinomial times a binomial. So now we're going to take the x squared and times the x. the x squared and times the 2. And just keep taking each term and multiply it through. It's kind of like foiling. We wouldn't officially call it FOIL. Because it's not a front or outer, inner, last concept. We group our like terms together. We have x cubes. The x squared is going to cross out. Here, when we group these two together, we would have negative 3x and a plus 2. So notice that we first multiplied two binomials together. Then we multiplied our third binomial into there. Now we have our 3. Because we have 3 sets of x's all to the first power, we can tell that this is going to be a cubic equation. It's kind of like when we were looking at graphing this type of polynomial. We were talking about how it was an odd degree. Now we're able to see that that is in fact a cubic, which is an odd degree, because they had an odd number of x's to multiply together. So you go ahead and try this one. You can group together any of the two binomials you want. If you want to multiply the first two together or the last two together, that's up to you. What we did the first time was to multiply the first two together. So I'm just kind of grouping those to get my eyes to focus on those first. You go ahead and try that, pause the video, then come back and see how you did. So we'll say a times a is a squared. A times 2 is 2a, negative 5a, and negative 10. Then we can group our like terms together, our a's, and we have this a squared minus 3a minus 10. We FOILed that together. Fronter, outer, inner, last. Now we're going to multiply that to the binomial at the end. So the a squared times the a. So the 1 in front times the 1 in front gives you a 1 as your coefficient. Since the a's are the same, the exponents get added together. 3 and 1, or 2 and 1 gives you a total of 3. A squared times 6. 6a squared. Then you take your next term and you multiply through. So that's negative 3a squared, negative 18a. Then you take your last term and multiply through. Negative 10a, negative 60. Grouping your like terms, you know you have a cubed, and your squares make a positive 3a squared, and your a's make a negative 28a, and your negative 60. So you've grouped together all your like terms. This came from multiplying 3 binomials together. We've talked about graphing binomials and what that might look like. This would be the standard form of that type of equation. All right, on the flip side. Maybe a little dark in the video, but on your sheet of paper, you can see our shortcuts. Now, I wouldn't say that these shortcuts are really needed. By the time you go through and multiply these out, you'd probably be at the same location as you trying to memorize what the patterns were. It's the same exact patterns as when you were factoring. Here you have 2 conjugates. So with 2 conjugates, when you multiply them out, you're going to have the middle terms cross out. So this is just going to come and be a squared minus b squared. The middle terms are going to cross out in conjugates. So just like when we were factoring, when you're subtracting two perfect squares, you make these conjugates. Well, when you multiply those conjugates together, you're going to make the a squared minus b squared. Same thing here. When you are squaring two binomials, you're going to get the a squared. You're going to get 2 times a times b, and you're going to get b squared. That might be more memorizing than you have to do. You just FOIL it together, you'd make the same thing. But these are some patterns that you could be aware of. So when we multiply, we get 25y squared. If you use your eyes real quick, you'll notice that that would be a positive 15 and a negative 15, which would cross out. So our final term would just be negative 9. These are conjugates. 5y minus 3, 5y plus 3. The only difference is in plus or minus. So that makes the middle terms cross out. We get the same thing here on the other side. 3h and 3h. 3 times 3 is 9. H and h is h squared. When you FOIL the outer and the inner, you get negative 21 and positive 21. That makes 0. So we just say negative 49. A positive and a negative make it a minus. 7 and 7 multiply to be 49. We have our special pattern of when we are squaring a binomial. One suggestion would be just to write them out as two binomials and FOIL it together. That would probably be the most reasonable. But do notice that it's just 4a that's being squared, and it's 2 times the 4a times the 7, and then it's the 7 being squared. So in terms of a pattern, this would give us 16a squared plus 56a plus 49. If you know of the patterns and recognize that it's a pattern type problem, you might enjoy setting it up in that fashion. This is 9x minus 2, and it's being squared. Your f of x function is 9x minus 2, and you're going to square the f of x function. So that's going to tell us that we're going to say 9x is going to be squared, then 2 times 9x and negative 2, 9x and negative 2, and then we are going to square negative 2. Well, that gives us 81x squared minus 36x plus 4. A negative 2 times a negative 2 is a positive 4. All right. So now down here for a couple of the application problems. We have these two models down here, which is D standing for the depth and C standing for the cost. We have the average depth in feet of a new well that's being drilled and the average cost per foot of drilling a new well. Both models, T represents number of years since 1980. So in 1980, it looks like 4,010 feet was a common depth, apparently. And the cost, you would plug in a 1, or a 0 actually, and it was $79. And then 1 year later, you could start to see what the costs were and what the depths were. So to figure out, find a model for the average total cost. It would be your depth times the cost of the depth. That would be multiplying. What operation would you need to perform on D and C to find the model for the average total cost of drilling the well. That would be the depth times the cost. Next we have a pyramid. We have the 3 different dimensions. We're trying to find the volume. Remember from geometry that the volume is 1/3 the area of the base. That's why it's a capital B. The area of the base times the height. So the volume is going to be 1/3 the area of the base, which is length and width, then times the height. And this is pointing to the line that's inside, which is perpendicular to the base, which is 3x plus 4. Then you can multiply that all together. That would give us 1/3. When we multiply these two together, we're going to get 4x squared, -6 and -6, which gives us -12x, plus 9. And then we have to come through and multiply again. So 4 times 3 is 12x cubed. 4 times 4 is 16x squared. -36x squared. -48x plus 27x plus 36. When we group our like terms together, we have 12x cubes. The squares get grouped together here, and it looks like that's 20. So -20x squared. These x's get grouped together. Looks like there's more negatives, so it's a minus. Take away 27, looks like 21x. And then you have the 36. Then we would distribute our 3 all the way through. So this is 4x cubed minus 20 over 3x squared minus 7x plus 12. So we did the same idea of 3 binomials all getting multiplied together. So we did all that the same. Then at the very end, we had to come through and distribute our constant number through. So I did that pretty quick, but it's just doing the same type of process that we've been working on. So go ahead, look at this problem, think about what this one's trying to tell you. How would you set the problem up? Setting it up is the biggest challenge. Solving it is just a matter of doing what we've talked about. But how do you set this one up? Go ahead, pause the video. Once you get your equation set up, come back and we'll finish it off for you. We have our square minus the rectangle. That's going to be the total area of the shaded region. So the area of the square is going to be x plus 1 squared, because it's square, so you have that binomial squared. And the area of the rectangle is length times width. So this is going to become x squared plus 2 times those two multiplied together and 1 squared. Then we're going to minus 5x minus 35 and distribute that through. And collect our like terms. So there are some like terms to get x squared minus 3x, and then our like terms plus 36. That would be our polynomial expression. for the area of this figure.